Section 3.3. When do we use systems of equations? Well, we use systems of equations when we have some word problems. So that's what we're going to do in 3.3. Number 1 says, the table below shows the number of U.S. households with PCs in millions and the number of U.S. households in millions since 2002. So you've got the year, you've got number of households with PCs, and total number of households. These data sets can be modeled by P of t equals 3.18t plus 67.92, and H of t equals 1.19 plus 107.36, where t is the time since 2000, P of t is the number of households with PCs, and H of t is the total number of households. How do you think they got those equations? Okay, so we had a bunch of data with years and numbers. So if I give you a bunch of data with years and numbers, how do you come up with, for example, this P of t equation?
We have the points for a graph right there that 2002 says since 2002, so 2002 would be since 2000, so 2002 would be 2.
So 2002 would be the year 2, because it was since 2000, so this would be the year 2, 3, 4, 5, 6. Okay, and then what do I do?
Then your other point on the graph would be 74.1, 7.5.
Okay. Yep. And then? That would work if you only picked 2 points. My guess is that's not what they did, though. My guess is they took 2, 3, 4, 5, 6, typed that into L1, took these numbers, typed them into L2, and then did what? That linear regression thing that we did on our calculator a while ago. So my guess is that's how they came up with these 2 equations. My guess is they entered the data into the calculator, did the linear regressions, got the equations. All right, well, the good news is we do have the equations. Anytime you have a word problem and they give you the equations, that's really the hardest part of the work. So this problem shouldn't be too bad. Part A. Find the slopes of P of t and H of t. What do they mean in this situation? All right, so for P of t, what's the slope? Slope is 3.18. How do you know that's the slope? Because it's in mx plus b form, and that's the m number, correct. And how about for H of t, what's the slope? 1.19. Same reason. This is an mx plus b form. All right, what do those slopes mean? So what does the number 3.18 mean about the data and the information you were given? Each year, what's increasing by that much? So, number of PCs, number of households with PCs increases by 3.18 million per year. That's what that number tells me. Roughly 3 million households per year are getting a PC for the first time. And the slope for H of t is 1.19. What does that tell us? The number of households increases by 1.19 million per year. All right, part B. Since the number of U.S. households is increasing, it is not surprising that the number of households with PCs is also increasing. Explain why that is not the only reason why the number of households with PCs is increasing. So what's happening? How much are the houses increasing by? 1.9 million, but the number of households with PCs is increasing by 3.18 million. So there's roughly 2 million old houses getting PCs. How come? Why are people getting PCs in their house? Because technology is what? Technology is advancing. Technology is getting cheaper. What else is happening? Much more stuff is going online. So I think those are the sort of things I would write for B. I'm not going to write that out. But I would write out, we're gaining roughly 2 million households with PCs per year. And the reasons are technology is becoming more important in everyday life. The price of technology is going down. People are using technology more and more. Part C. Predict the percentage of U.S. households that will have PCs in 2013. What do you do there? We start at 2000, so 2013, T would be 13 years. So T is 13. What am I going to do with 13? Plug it in for T in the first equation. Okay, so I'm going to take P at 13. I'm going to plug it in. I'm just going to use my calculator. So I'm going to have 3.18 times 13 plus 67.92. 109.26. Okay, so what does that number tell me? No, it doesn't tell me how much it's increased. This tells me how many households in millions have PCs in them. So this says 109.26 million households will have PCs. So this is number of households with PCs. That's correct. The directions said predict the percentage of U.S. households. That is not the percentage. That's just the total number of households that will have PCs. So that's not the final answer. I agree. So what do I do now? I need to plug 13 in for the other equation. And when I plug 13 in for the other equation, I'll get a number. We'll figure out what that number is here in just a second. What is that number going to tell me?
How many households are?
This will be number of households altogether. And how will I find my final answer? How will I find the percent of households with PCs? Well, let's find that number first. So I plug 13 in. I'm going to have 1.19 times 13 plus 107.36. 122.83. So if I know there are 109.26 million households with PCs and 122.83 households total, how do I figure out what percentage of the households have PCs in them? I divide those two numbers. So I'm going to take 109.26 and divide it by 122.83. I get 0.8895. So what would I write for my final answer? We'll call it 89%. So this year we predict that 89% of all households in the United States will have PCs in them. Is that believable?
Yeah.
I think it's believable. Even though it's quite a ways out of our data, isn't it? That's 7 years outside of our data set. So that would be an example of extrapolation. But I still think it's relatively believable, I think. Well, it depends on what you count as a PC, I suppose. Are you going to count an iPad as a PC? Because lots of people now have iPads. They don't have PCs in their house anymore. Let's just call it computer, I guess, and then I think it's believable. All right, finally, part D. Predict when all U.S. households will have PCs. How am I going to predict when all U.S. households will have PCs? I can guess, that's true. I guess the year 2020. Is that a good guess? Oh, maybe it is, I don't know. Can I do better than guessing?
2006 to 2013 is only about 3%.
Okay.
So that's 7. So I have to be
At least another 20 years? Okay, so I'll guess 2033. I still don't think guessing is a good way to go. I need a better way. Well, I have a formula. Don't I have a formula for number of houses with PCs? And don't I have another formula for number of houses? And it says, I want all the households to have PCs. This is a system of equations, and that's exactly right. We want the number of PC households, which is that formula right there, to be the same as the total number of households. Basically, they're asking us to solve that system of equations. So, I have 3.18t plus 67.92. That's all the households with computers. And I want that to equal all the households. So I think they're just asking us to solve that system of equations. And in this case, I chose to use the substitution method to solve. Why did I choose to use the substitution method? Basically, we already had y all by itself. Instead of using the letter y, we use the symbol h of t, and we use the symbol p of t, but those are really y. All right, so I solved this equation. I'm going to subtract 1.19t on both sides. 3.18 minus 1.19. 1.99t plus 67.92 is 107.36. Subtract the 67.92. 1.99t equals 107.36 minus 67.92, 39.44. Divide by 1.99. I predict it's going to take t equals 19.8 years. Yeah, my guess of 20 years was pretty good, wasn't it? Actually, I just did guess. I had no idea what the answer was. It really, truly was a guess. So I would say the year 2020, because we started in the year 2000, it says. T is years since 2000. Is that back there? My guess would be the year 2020. Do you believe that? Do you believe that in the year 2020, every house in the United States will have a computer in it? Just about. I think it'll be close. I'd be surprised if we ever actually reach exactly 100%. But I think in the year 2020, it's going to be pretty close that every house will have a computer in it. All right, number 2. The percentage of students studying for a Master of Divinity degree who are women versus those who are men is shown below. What's a Master of Divinity degree? Who earns a Master of Divinity? Clergy. So this would be somebody who wants to be a clergyman. Or a clergywoman. Depending. Let W of t and M of t be the percentage of divinity majors who are women and men respectively, t years since 1990. Determine the equations for W and M. All right, so far it's very similar to the last problem, except the big difference is they do not give us the equations this time. This time we need to figure them out. So I think this time we're going to need to use our calculators. So the first thing I need to do is I need to type in the data for the years. So I'm going to go stat, edit, and my lists are already empty. That's nice. Except we got to be careful. T is years since 1990, so I'm not going to type in 1993. I'm going to type in 3. So it's going to be 3, 6, 8, 10, 12, and 15. And then I'll move over and I'll type in the data for women. So the data for women would be 25, 28, 30, 31, 32, and 36. Okay, we'll type in the next one too as long as we're here. But then we'll have to be a little bit careful when we go to find our equations, and we'll talk about that. So we might as well type this one in, 75, 72, 70, 69, 68, and 64. We'll type in all the data. Quit out of that. Second, quit. All right, now how do I find the equations? Stat. Move over to calculate. Linear regression. And I have the older model calculator, so mine just looks like that. And then I hit enter again, and it gives me an equation. Y equals, how many decimal places do we want to round off to? 2 decimal places? All right, so is this the formula for women or is this the formula for men? Women. How do you know this one's the women one? Because we typed in that one first. Okay. So for women, W of T is, we decided 2 decimal places, so we'll call that 0.86T plus 22.61. So there's my formula for women. Now, how do I find the formula for men? All right, so I go stat, calculate, linear regression, second 3. Close. That gives me an error, but you were so very close. It is L1, L3. So what you need to do, if you want to use, by default, the calculator will always use L1 and L2, unless you tell it otherwise. So since we typed our data into L3, I need to go stat, calculate, linear regression, and then I need to tell it my X numbers are in L1, so I go second L1, comma, second 3, my Y numbers are in L3. Or if you have the new type calculator, down where it says X list, you'll have L1. If you go down to where it says Y list, you need to change that to be L3. Okay, if you have the newer type calculator. So there's my formula for men. So M of T is negative 0.86T plus 77.39. All right, so this one was a little bit harder because we had to figure out the equations. And that happens sometimes. Part B, compare the slopes of the models. Okay, so what's the slope for women? For women, slope is 0.86. And what's the slope for men? Negative 0.86. What do these slopes mean in this situation? Well, they have the same slope, but one of them's positive, one of them's negative. Well, they're not. The lines are not perpendicular. What would it have to be for the lines to be perpendicular? They'd have to be negative reciprocals. So it would have to be 0.86 and negative 1 divided by 0.86. No, the lines are not parallel. What would it have to be for the lines to be parallel? It'd have to be exactly the same, but one of them's positive, one of them's negative. Well, one's going up, so one's going up in this direction, one's coming down in this direction, so they're definitely going to cross. Definitely not parallel. But what do these numbers mean? What does 0.86 mean in terms of Master of Divinity degree?
At the same rate that the woman is raising this, men are dropping at that same rate.
And how fast are the women raising?
0.86
0.86% per year. So what this number means is the number of women earning the degree is increasing by 0.86 per year. So conversely, if the number of women is going up by 0.86 per year, the number of men has to go down by 0.86 per year. All right, so I'll write that down. Number of women earning the degree increases by 0.86% per year. And conversely, the number of men decreases by 0.86% per year. So, notice that at the beginning, there were a lot fewer women than men earning the degree, but the percent for women is going up while the percent for men is coming down. So eventually they ought to cross, right? Eventually, the percent of women earning the degree should be exactly the same as the percentage of men earning the degree. And that's question C. When will that happen? Predict when the number of women studying for the Master of Divinity degree will equal the number of men studying for such a degree. What are they asking us to do? Solve the system of equations. And again, I think for the system, I think the substitution way is pretty good to go because this one has y all by itself and that one also has y all by itself. So I'm just going to take those two equations and make them equal to each other. 0.86t plus 22.61 equals negative 0.86t plus 77.39. Add the 0.86t to both sides. 0.86 plus 0.86 is 1.72 t plus 22.61 equals 77.39. Subtract 22.61. 77.39 minus 22.61. 5478 is equal to 1.72 t. So t is, let's call it 32 years. 31.8, we're going to call it 32 years. So, seeing as we started in 1990, when is 32 years after 1990? The year 2022 would be our answer. Are we highly confident of that answer or not so much? Not so much would be my response to that. Why not? Too many years from our data. Our data stopped at 2005. To talk about what's going to happen 17 years later, I think is unrealistic. But it is our prediction. It might happen, it might not. Number 3. You get to try number 3 on your own. Well, you have to do it on your own. You can use your friends. You can use your neighbors. Give it a shot. See how you do. All right, let's run through this one real quick. In 2007, a Honda Accord was worth about $18,329 with a depreciation of about $2,256 per year. All right, so we want to find a formula for Honda. Which number is the slope? 2256. What tells you that that number is the slope? per year. Okay, again, that's the big key. A lot of you had that reversed as I was walking around. You didn't have that number for the slope. So the slope is 2256, except in this case it has to be negative. What tells you the slope has to be negative? It's depreciating. The value of the car is going down. Plus, the y-intercept is how much the car was worth at the beginning. How much was the car worth at the beginning? 18,329. And then you're going to do pretty much the exact same thing for the savings account. For the savings account, we started with $500 in 2008, and we're increasing by $1,700 per year. So again, which one's the slope? 1,700. Plus, we started with $500. So this reminds me an awful lot of the problems we did in Section 2.4. It's almost exactly the same as what we did in 2.4, except you got to do it twice. You got to find two equations. In 2.4, we only had to find one equation. Here, we got to do it twice. Predict when the student will be able to buy the 2007 Honda Accord and pay cash. What are they asking you to do there? Set the system equal to each other. So minus 2256t plus 18329 equals 1700t plus 500. How do you solve that equation? You chose to do plus 2256t on both sides? Because you don't like negatives? That's as good an answer as any. 18329 equals 3956t plus 500 minus 500 on both sides. 17829 equals 3956t. Divide by 3956. T is 4.5 years. And seeing as we started in 2008, somewhere between 2012 and 2013, kind of in the middle of 2012, right? So I would put maybe that. Maybe I would put mid 2012. Go ahead.
When I did that, I forgot to make the, negative 22,000, or whatever.
Uh-huh.
I did plus for minus 18, and I got 4.76, which, even though it's pretty close, it's wrong, because they're still, close.
It shouldn't matter. If you did the minus 18,329 and move that to this side, and did minus 1,700 and move that to that side, you should get exactly the same answer. My guess would be you might have typed a number wrong into your calculator.
I know that.
Did you have negative 17,829?
No.
What did you have there?
Oh, yeah. I just did it wrong.
Okay, so you made an arithmetic mistake there. Yep. Okay, so we predict that he will be able to pay for the car using cash in 4.5 years. Part C. Now assume the student earns interest on a savings. Is your answer in Part B an underestimate or an overestimate? Overestimate. How come? If he has savings earning interest, he'll have more money. If he has more money, he'll be able to buy the car a little bit sooner. So it's an overestimate. Interest will give him more money, he can buy the car sooner.